In this video, we're going to solve some questions about domain and range. And just to remind us at the beginning here, domain, of course, is all the possible x values, and the range is going to be the resultant y values. So independent, dependent variables, domain x, range y. So in this example, f of x equal x squared plus 4, we need to think, okay, what are we allowed to put in for x? That's our domain. So our domain is all the values of x such that x gives us an answer. And in this case, x can be any real number. So we say x belongs to the set of real numbers. And that's the range. Doesn't matter what you put in for x, negative, 0, or positive, you get one answer for y. The range then, well, the range, we need to think about what happens when we plug in values of x. And so if we think through it, if we put in a value of x and then square it, we know this is always positive. It doesn't matter what goes in here, it's always positive, unless we put in 0, in which case it's 0. So maybe we should say it's always positive or equal to 0. If x squared is always positive or equal to 0, that means that x squared plus 4 is always bigger than or equal to 4. We just add 4 to both sides. That tells me the range is f of x such that f of x is always greater than or equal to 4, and it belongs to the set of real numbers. We could also look at the graph to determine the range. So if we bring up the graph, x squared plus 4 here, and we'll graph it, we can see it cuts through the y-axis at what looks to be about 4. We'll zoom in and have a look now in a second. But we can see there's no values below the y or below the x-axis. They're all positive, and there's no values down here. This is a parabola shape opening up. If we zoom in to around where the vertex or the smallest point is, we can see this would be 2, 3, 4. And if we move our cursor around it, you see it's about 4. If you want to calculate the value, we know that this is the point where x is 0. We find that that point is y equal 4. And that's why we have f of x such that it's greater than or equal to 4. So the next example, the domain. Again, what can we put in for x? And here, if we put in negative, positive, or 0, we get an answer. So any value is fine for the first x, x to the 6. X to the 4, again, doesn't matter what we put in. Remember, we're trying to look for two things. Do we have a denominator or do we have a radical? In this case, we don't have either. And so we can say the domain is x such that x is all real numbers. And y, we're actually going to get the same answer for the range. And if we look at our graph again, we'll graph the second one now. Bring it up. And the shape is a bit different. It's similar, but it's flatter along the bottom. And again, we're crossing through exactly the same point. If I calculate the value when x is 0 here, again, the smallest point is 4. So the range is all y such that, or h of x, y is greater than or equal to 4, and y is a real number. The next function, we're just asked to find the domain, and this has a denominator. So as soon as we see the denominator, we know that the denominator cannot be 0, because division by 0 is impossible. We solve for x then, and we find right away the domain is x such that x cannot be equal to 2. And all other real numbers are fine. And we'll go to the final example here. Here we have two things. We have a denominator, so we know that the bottom cannot equal 0. But also we have a root, and that tells us that the part under the root has to be greater than or equal to 0. But I want you to think for a second. If the root is greater than or equal to 0, well, if the root is equal 0, the whole bottom equals 0. In that case, the top one doesn't make any sense. So in this example, because the root is on the bottom, we just have to say x plus 4 needs to be greater than 0. It has to be positive because it's under a root, and it can't be 0 because of this first thing we wrote. So if we go ahead then, we find that x must be greater than -4. And if we write that in our notation, we get x such that x is greater than -4, and it's a real number. So that's some examples about domain and range. Remember, you want to focus on, is there a denominator, is there a root, or a radical? If both those things are not there, you get what we had in example 1 or 2, where the domain is all real numbers. For the range right now, continue to focus on getting the graph, seeing where the y values are, and drawing your conclusions that way.